The next topic is pattern matching. Let's see what we have. Let's start with an example to understand the pattern matching facility which is available in Scala. Here is one function, do show, and that function takes one parameter, show is the string, and the function returns a string, correct? Now the body of the function is just one line. You can see that because after equal, just one line, right? And that line has a keyword match. And what we are doing here, we are trying to match the possible patterns with the parameter. So if the parameter show falls in the case of clean dishes, so in other words, if the parameter show is the string clean dishes, then this will be the evaluation output of this line. So in other words, this whole line, I'm talking about this and this whole thing, this whole line will evaluate to the string. Remember this arrow symbol. Okay. In other case, when parameter show is cooked dinner, just an arbitrary example, then that will be the evaluation output. And in all other cases, this will be the evaluation output. So how it goes with some invocation of this function do show. So here we are invoking function do show with this argument clean dishes. So that means show in this situation is clean dishes. So this should be the print of this line, correct? For this line of code, the show is matching with this case, and that's why the output of this line will be complaint, correct? So you can see using this match keyword, we can match different cases for one variable, and that can lead to different evaluation for that variable, correct? Okay. Another example, we are using factorial function, and here the input is n, and if n matches with 0, then output is 1. Remember, factorial 0 is 1. And in other case, we are doing something else, right? Now here, another interesting thing to see that in other case, we can also add an extra condition. So here we are checking whether x is greater than 0, and then only this will be the evaluation of this case, and that is doing the recursion, right? Okay, so this is the way to call this function, and the output should be factorial of 3, which is 6. Another example, we can also implement Fibonacci with this concept. So if n matches with 1, output is 1. If n matches with 2, output is 1. Otherwise, this guard concept is there. If x greater than 2, then this will be the evaluation, and there we are doing recursion. So remember, this guard concept allows us to exclude the bad cases, because you understand that somebody can feed a negative number to this function, and that should be out of all these cases. So this guard allows us to do that in a succinct way. Okay. Now not only in function definition we can use this pattern matching, in other code also we can use. This is an interesting one. Here second element is a variable, and that is equal to whatever is the output of this match. And what this match does here, this is a list, and we are trying to match that list with these many cases. If the list matches with this case, what this means? This means this list matches with a head concatenated with a tail. So this is the concatenation operation. This is head, this is tail. These are arbitrary variable names. You can have any other name, that is fine. But this whole thing together means this is a list which can be deconstructed in head and tail, almost like what we saw in prologue, correct? So that means if this list is not empty, this pattern will be matched, and in that situation, the head of the list, the head of the second part of this list, that means the second element of the list, correct, that will be returned. If for some reason this list is empty, that will match with this case, and for some reason we are returning 0. You can return anything else depending on your situation. So if we run this code, the value of second element should be what? The second element of this list, correct? Okay. Now take some more example. Say this is a list which has some arbitrary integers, and now we are trying to find whether this list has an integer whose remainder when divided by 2 is not 0. That means, in other words, we are trying to find an integer which is odd number in this list, right? There are multiple odd numbers, and what find does, it returns the first one. But interestingly, this find function in list will return not raw 29, it will return 29 packaged within another object called sum. Okay, and let's see another example to understand the motivation. So this is another list which only have even numbers, and if we try to find the odd number in this list just like before, then in this example there is no odd number. So then what it should return? The Scala will return a value called none. Now you see the challenge here, right? Find is a function which is applied in this case and this case. So a function always returns one type of output, right? There has to be a type of the output of function. So in one case we see this should return 29, in another case this should return nothing. So then what will be the common type of this? So you see the challenge of designing such a function find, right? To solve that challenge, Scala has this option class, this option concept, which can be even customized to int. So what does it mean? It means that there can be some integer, and in some other cases there may not be an integer, and both of these cases are under this option class or option int type. So that means sum 29 is a valid option int type, none is also a valid option int type. In this way we solve that previous challenge I talked about, correct? Another exercise, so list, and we are trying to find the integer in this list which is greater than 11. So that should return the first one, right? And in this situation it should not return just raw 20, and it should return sum 20, correct? And in this case, when the condition is greater than 50, we are trying to find the element which is greater than 50. There is nothing like that, and that should return none. Okay, and using this option concept and sum and none concept, you can do many other sophisticated programming. This example here shows, given a sum which encapsulates this integer, or I should say this double 10.o, uh, how we can extract the inner double given such an option. That is the challenge here, and we can use match. So we are matching whether this a value is of this type, and if this is the case, we can return v, the inner part, and if this is none, then we can return something else, and in as an example 0.0. So this value should be how much? This was 10.0, so it matches with this condition, so this value should be 10.0 here, correct? And in other case, b value is none, so if we do similar matching with this value, with this b value, then that should match with none case, and that means it should return 0.0, so the value of value 2 should be 0.0 after this code is run, right? Okay,